Lab 1, Group L3.
This lab investigates the basis of calibrations as well as how calibrations work. An Arduino Uno is being used, which is a microcontroller that allows us to hook up the load cell and accelerometer to calculate the ADC values versus mass and the ADC values versus acceleration in the x direction. Those were the main tasks of this lab. A load cell converts the load into electrical signals, which the amplifier performs a 24-bit conversion on. The accelerometer measures the acceleration in the x direction by producing a voltage proportional to the acceleration, as well as the acceleration component of gravity.
So, as far as the results are concerned, the objective was to collect data, plot a graph, and generate a regression line. For the load cell, the line of best fit would help determine the mass of the object placed on the load cell, given that we know the generated ADC values. Whereas for the accelerometer, the line of best fit would help determine the acceleration due to gravity of the accelerometer, given that we know the yielded ADC values. Looking into the plots, we can note that for the load cell, the yielded values have a high precision, which is depicted by all the points sitting on the regression line. However, the accuracy of the load cell can be affected by the environment, since also airflow could affect the reading. For the accelerometer, we can note that the precision is low since the values lie off of the regression line. From figure 3, we can also see that the accuracy of the accelerometer is low, since for this sample collection, we expected our values of gravitation to be 0 or close to 0.
This lab had two main parts, load cell calibration and accelerometer calibration. The methods were very similar for each part. First, we had to hook up the measuring devices. In the first part, this was the load cell, and in the second part, this was the accelerometer. Next, we collected data, better known as ADC values, for known quantities. In the first part, this was samples of known mass, and in the second part, we placed the accelerometer at angles that we knew, which we could then use to figure out the gravitational acceleration for those angles. We then collected data of unknown random objects. In the first part, this was 3 random objects, and in the second part, we moved the accelerometer around on the table randomly. We then analyzed the data and created equations relating ADC values to mass and acceleration. Finally, for the last part of the lab, we used these equations to compute the mass and acceleration of our random samples.